In this short video, we're going to do some review problems for the Exponents benchmark. Many of these come off the worksheet homework that you had. We're going to start off with negative exponents, and just a reminder that a negative exponent moves something on the numerator to the denominator, or something in the denominator to the numerator. So in this very first problem, we have 10 to the negative 2. That's the same thing as 1 over 10 squared, or 1 over 100, and we're done with that problem. Over here, we can simply say, oh, if I've got a negative 1 power, it's going to flip my fraction, because 2 to the negative 1 would go to the bottom as 2 to the first, 3 to the negative 1 on the bottom would go to the top as 3 to the first. When we go to number 8, we're going to flip and square. Let's flip first. Now my exponent is positive. Now I square it, and I'm done. Same thing here. It wasn't a fraction, but we can first flip it 1/2 to the 5th. And now we can say, well, that's going to be 1 over 32. We actually took the 1 to the 5th power. 1 to the 5th is 1. And 2 to the 5th is 32. On this next slide, we're going to look at our fractional powers. And remember, when we have a fractional power, a over b, so if we have, say, x to the a over b, the bottom is our root, and the top is our power. So when I do this first one, my root is 2. So I'm going to take the square root of top and bottom. Square root of 4 is 2. Square root of 49 is 7. So here I took the square root of the top and the bottom. Here I've got a 3 on the bottom, so I'm going to take the cube root. And I think to myself, what do I cube to get 27? And my answer is 3, because 3 cubed equals 27. On this next one, we're going to have 2 steps. First, we're going to have a 4th root, and then we're going to cube it. So we have to say to ourselves, well, what to the 4th power is 81? And we should recall that 3 to the 4th equals 81. And now we're left with 3 cubed. Notice we did the root first. And when we do 3 cubed, we get 27, which we reviewed right over here. On this next slide, we're going to combine things. So here I've got 27 over 64 to the negative 2/3. My first step is to flip it and work with a positive fractional exponent. So there we go, 2/3. On the top, I take the cube root of 64 because I have a 3 on the bottom. Cube root of 64 is 4. 4 squared is 16. On the bottom, cube root of 27 is 3. 3 squared is 9. And I'm done. In this next one, again I have a negative, so I'm going to switch this to 1 over 125 to the 1/3. And the cube root of 125 is 5, and so I've got 1/5. All right, we want to also explore what's the difference between the negative here and a negative up here. So this is problem number 9, and here we're going to flip. So we get 1 over negative 11 squared. And we want to notice that we have an even power. An even power is going to take negative 11 times negative 11, or 1 over 121. We're going to explore here 3 cases. So here we go. We have an odd power. And since we have an odd power, we're still going to have a negative. Because remember, the negatives cancel off in pairs. We have 1 left over. Our answer is negative 8. Here, this is not taken to the cube, so the negative just tags along. 2 to the 3rd is 8. Over here, I have negative 2 to the negative 3rd. Well, that's 1 over negative 2 cubed, and so I get 1 over negative 8. Down here, I have an even power. Negative 3 squared is going to be a positive 9 because I'm working with an even power. Now here, even though it's an even power, that negative is just out front. The 2 does not, the squared, does not affect that because it's not in parentheses. It only squares the 3, which is 9. And in this case, we've got 1 over negative 3 squared, and we get positive 1/9. All right, we also need to be able to work with variables. So let's take a look at these. In this first case, this is a situation where we add exponents. A to the 7th times b to the negative third, our answers have to have all positive exponents. The a to the seventh already has a positive exponent, so it just stays where it is. But the b to the negative third, to get a positive exponent, it moves down to the denominator. This next problem is one where we multiply our exponents, so we end up with c to the fifth, d to the negative 15th, and we've got the same situation as the last one, where c to the fifth is already positive, and d to the negative 15th, in order to write it with a positive exponent, it goes in the denominator. All right, here we're going to combine some rules. H times h cubed, we add our exponents, h to the fourth over h to the 10th. Now we have two choices. We could simply say, hey, when I cancel and subtract, I'm going to have more h's on the bottom. I get h to the sixth. Sometimes you might subtract. If you subtract, you would get h to the negative sixth, and then you would rewrite it as 1 over h to the sixth. Notice in either case we get the same answer. All right, in this last one, perhaps you would multiply exponents first. F to the negative 15th over g to the negative 5th. You'll notice they're both negative, so they're both going to have to move. F to the negative 15th comes down here, f to the positive 15th, and g to the negative 5th down here comes up here, g to the positive 5th. All right, our last set of examples on here is to see the difference of having parentheses again. When I have 3k to the 0, the whole thing is taken to the 0 power, therefore it is 1. Over here, only k is to the 0 power, so I have 3 times 1, which is 3. Down here, the negative is on the outside, so I have negative 1 over e to the 6th, because this negative simply puts e in the denominator. And here, I get 1 over negative e to the 6th, but since 6 is an even power, that's going to be the same as 1 over e to the 6th, because my negatives, when I take it to the 6th power, all cancel out. All right, I hope that is helpful as you study for your benchmark.